together on our Iron Man 3 scene. How many of you have seen Iron Man 3? Awesome. There's a scene in Iron Man 3 where part of a plane blows up and people start falling out, and then Iron Man 3 goes after them to save them. I've got that clip for reference here. Yeah, pretty awesome, right? Okay, so from the clip on the left side, we've gathered the data that there's two chains of people, of 6 people in each chain, 1 female and 5 males in each chain of people, and the third female is on his back. And the starting altitude is 18,000 feet. The lowest known altitude that Jarvis tells them is 200 feet, so we assume that they can start decelerating at 200 feet because we have no other value for that. And then we did some research and gathered that the average terminal velocity for a human is 53 meters per second. So we're going to assume they're falling at terminal velocity at 200 feet above the water. The average mass of a male is 70 kilograms, female 61 kilograms. Strength of a shoulder tendon is 1891 kilograms per 9.8 meters squared per inch squared. And the safe impact velocity of a person falling into water and surviving was about 28 meters per second. So taking this data, what we need to find out is if they start decelerating at 200 feet above the water, what their maximum deceleration value is for them to withstand like the stress on their shoulder of the first person in the train and the speed that they hit the water. So to start off, I'll draw the diagram. So we have 200 feet and then the water. It's about 60.96 meters above the water. And they're traveling at terminal velocity, so that's 53 meters per second. Safe impact velocity is 28 meters per second. So for them to survive this situation, they have to hit the water at maximum 28 meters per second. So to find out their maximum deceleration, which is the force on the first person in the train, that's going to be the the strength of the tendon in the human shoulder, and times that by the mass of divided by the mass of one chain. So the strength of the human tendon is 1891 kilograms per 9.8 meters squared per inch squared. And the surface area of the tendon, the cross section is 0.457 inches squared. So you multiply that and you get a force strength of the human shoulder is 864 newtons. The ultimate strength of the shoulder. And then we know that the acceleration can be derived from the force over the mass. And the mass, which is 5 males at 70 kilograms and 1 female at 61 kilograms, that's 411.141 kilograms. So the acceleration is the force divided by the mass, which gives us 2 meters per second squared. So the maximum deceleration is 2 meters per second squared. So the resulting impact velocity, we can use the formula of velocity squared equals initial velocity squared plus 2 times the acceleration times the distance. And that gives us 50.6 meters squared. So the impact velocity is 50.6 meters per second. And that is 1.8 times faster than safe impact velocity. So they die. If Ironman decides to go faster than their maximum deceleration, so if this is Ironman right here, and the first person here, second person here, and so on. So if he decides to pull up faster than this person can hold on, they all break off and fall into the water even faster. So they die, ultimately. He did this in about, 18,000 feet. It was about 1.5 minutes of free falling time. And he caught them pretty much at the end. He would need like about a minute before impact to catch them all, to be able to save them. So that's Ironman.